Alright, here we are talking about solving quadratic equations. Today we're going to be focused on level 3. Okay. Just go ahead and take a second, pause the video, and see what you can do with this one. Okay. Now, a lot of people go for going with some sort of area, right? Focused on x squared, 6x, and 9. Okay, and that's equals 49. Or even if you subtract 9 from both sides, now you have x squared plus 6x, and this is a rectangle with an area of a 40. But we've already seen that a rectangle is hard to find. If we know the area of the rectangle, it's hard to find the dimensions, right? There's lots of different answers that it could be. So we want to try to take advantage of the symmetry of a square, right? We already have the x squared, so the key is being able to balance that, right? And we need to start thinking in a more in a larger way with the larger array. So if I go ahead and put the x squared here, if I want to balance 6x part on each side, okay, thinking about how we multiplied binomials, okay, if you haven't seen that video, check that one out, multiplying binomials. We can go ahead and put 3x here and 3x here, right? Because those add up to be our 6x, right? And so that's going to give us x here, and if we throw 9 here, positive 3 here, x here, positive 3 here, we can see that what we already have, this x squared plus 6x, right, plus 9, okay, what we already have here, right, this is a perfect square. Right? It's a perfect square in disguise. So that's the thing that we have to be on the lookout for in a problem like this. Okay, it looks complicated, it might look hard, but it's actually a level 2 in disguise, right? So now that we know that, we can go ahead and rewrite this as the x plus 3 quantity squared equals 49, and literally that now reverts back to that level 2 problem, right? We know we can take the square root here, but the key in thinking about this in terms of the area model is being able to utilize that symmetry. When it's not something just that's already a perfect square, we have to be on the lookout for how to take advantage of that symmetry. So from here we can finish it up with, right, if we wanted another square, right, it's got an area of 49, so that's side lengths of 7 and negative 7. We also know the side lengths are x plus 3, so x plus 3 is going to either be 7 or x plus 3 is going to be negative 7. Subtracting 3 from both sides, we get x equals 4 or x equals negative 10. Okay, you can check those and see what you get. All right. So let's go ahead and try another one of those. Okay, again, taking advantage of the supersymmetry that we have. Right here, we've got x squared. Okay, splitting this up, negative 4x here and negative 4x. And so does that give us what we want? Well, we'll have x and minus 4. Okay, with an x over here, that'll give us that. And same thing here, negative 4. So negative 4 and negative 4 is going to give us 16. Sure enough, that's what we wanted. Okay, plus 16 minus 8x, x squared. Okay, so this gives us all the terms that we want. Okay, so yes, we do have a perfect square. So again, we can rewrite this as x squared, or sorry, not x squared, x minus 4 quantity squared, and that's going to be equal to 63. Okay, from here, again, the method that we take to finish it is all relative, but we can finish it by taking the square root. We can think about that square, the square model, the area model, side length of x minus 4, and then we have side lengths that are equal to the square root of 63 and the negative square root of 63. Right, giving us two equations. X minus 4 equals square root of 63, or x minus 4 equals negative square root of 63. When we add 4 to both sides in each case, we have 4 plus the square root of 63, or x equals 4 minus the square root of 63. Okay. All right. So go ahead and go try the practice on your own. Again, these are level 2 perfect squares in disguise. Okay, use the area model to uncover that. Okay, and show that and be very clear in your practice. Okay, and if you have questions, come to see me in Zoom.